Welcome to the Check Your Understanding for 10.1c. To study the long-term effects of preschool programs for poor children, researchers designed an experiment. They recruited 123 children who had never attended preschool from low-income families in Michigan. Researchers randomly assigned 62 of the children to attend preschool, paid for by the study budget, and the other 61 to serve as a control group who would not go to preschool. One response variable of interest was the need for social services as adults. Over a 10-year period, 38 children in the preschool group and 49 in the control group have needed social services. Do these data provide convincing evidence that preschool reduces the later need for social services for children like the ones in the study? Justify your answer. So it doesn't say to do it, but anytime it says, do you have convincing evidence, you are going to go through a hypothesis test, a significance test. So identify that we have two populations here, and they're giving us a proportion of two populations because you're not going to know if this is a one sample Z-test for P or a two sample Z-test for P. It's not going to say, hey, go do this. You're going to have to read it and decide. So we know we have 49 out of 62 compared to 38 out of 61. So we do have some evidence that the preschool group had less need for social services. Actually, those proportions are pretty close, but we want to see if that's a significant difference. So we will go through the state plan, execute, and conclude that's necessary for a significance test. So in our state, remember to define your parameter and state your significance level and show your hypotheses. We will estimate P1 minus P2, the true difference in proportions of children in preschool, minus the control, who need social services as adults at the alpha equals 0.05 level. And make sure you're clear which one of these is the proportion of in preschool, so that's P1, and then P2 is the control. If you want, you can even do like P sub school, P sub control if you want to write it out in words instead of using 1 and 2, if that's kind of clear. Your null is that there's nothing unusual going on, that there's no difference between the proportions from these two populations. So P1 minus P2 is 0, that these would be the same. And then your alternate, we think that P1 would be a higher proportion. That's our alternate hypothesis. We think this would be a bigger number because P1 is, I'm sorry, scratch that. See how we have as less than 0? So that's implying this difference is negative. We think this P2 is bigger, that the control are going to have a higher proportion of adults who ended up needing social services. So this is bigger. That's why P1 minus P2, we expect that to be negative. That's our alternative. Now, if you switched up what you called P1 and P2, it could be greater than if you switch which one's which. So just make sure what you have makes sense. Here's our statistic. So we observed 19% difference. Now, because it's a significance test for proportions, we are going to get a combined p-hat. Because remember, we do a hypothesis test, assuming the null hypothesis that there's really no difference between these two groups. So for our standard deviation, we're going to use the pooled data, the p-hat combined, as if we just sampled 123 people and 87 out of those 123 needed social services. So we're going to use that 0.707. Okay, so then for the plan, we are going to name the test, two sample Z-test for P1 minus P2, and state our conditions. We need to pass the random condition for both. They randomly assigned to preschool and a control. So make sure you're not writing like randomly sampled. We had random assignment. That's what's needed here since it's an experiment. So it's two groups in a randomized experiment. The 10%, this is new. We do not need to check this. So this only applies when a sample is randomly selected without replacement from the population. These subjects were not selected at random. We don't have to worry about that kind of independence. So this is something you need to think about is, do I need to check the 10% condition? because you should only be checking that if you're sampling without replacement. And in this case, we are not. For normality, for the sampling distribution of P1 minus P2 to be normal, or sorry, P hat 1 minus P hat 2, you need to pass the large counts for both. Execute. So the mean and standard deviation, notice how you are using P hat combined here. Right, that pooled. Test statistic, stat minus null divided by standard deviation. Look at that formula. But realize that's just the statistic, which is the difference in p hats, minus the null value, which is going to be 0 for these significance tests, P1 minus P2, because you're assuming there's no difference, divided by that standard deviation, which you have right here. Draw out your curve. So the middle will always be 0, that mean, for our hypothesis test. And then we want to know the probability of observing a difference of negative 0.19 or something more extreme, less than that. So here's calculating that test statistic. It should be negative 2.32. To get that p-value, you can use table A or normal CDF. We're cutting it close to the 10% significant, no, the 1%. So 0.0102. So we do have significant results at the 5% level. So we will compare that p-value to alpha. Because our p-value of 0.0102 is less than alpha, we will reject the null hypothesis. There is convincing evidence to support the alternative, that the true proportion of children, like those, notice this, like those in the study who attend preschool use social services less than those who do not. This really is a small detail in the conclusion that's very important. We didn't randomly select the people in the study, did we? Let's go back and check. Oop. They recruited. So it doesn't say anything about randomly selecting low-income families. So whatever conclusions you make, you can't generalize to a broader population. We have random assignment, so we can conclude cause and effect, but we cannot generalize to a broader population because it's just random assignment, not random selection. So that really affected our problem. It affected the conditions. Sorry, I'm like going back and forth. Where is that? Here, where we didn't need to check because it wasn't randomly selected. We didn't have to worry about that independence issue. And in our conclusion, we can only conclude to children like these in the study. Can't generalize to a bigger population. So be careful with that. All right. Oh, there's still another question. Based on your conclusion to question 1, could you have made a type 1 error or a type 2 error? All right, type 1 error. Both of these are always possible. Even though we got a very low p-value, that doesn't guarantee we didn't just happen to have high variability in our sampling, like that happened to get something rare. Now, we didn't make a type 2 error because a type 2 error happens when you fail to reject the null hypothesis. And we didn't do that. We rejected the null. So it's possible we made a type 1 error, which the probability of that happening is your significance level. 5% of the time, you're going to get an observation that you think is so rare, you're going to reject. But it's still possible 5% of the time. So it's possible we could have made a type 1 error. All right, that was quite a juicy check your understanding. So hopefully you took all that in.